Antiderivatives. We've already worked a little bit with antiderivatives, but in discussing the fundamental theorem of calculus as a shortcut for finding definite integrals, and we can as a starting place in sort of evaluating antiderivatives, we can start with the our rules for derivatives and just to kind of reverse the rules for derivatives. In general, antiderivatives are it's more challenging to find an antiderivative for a function than it is to find the derivative. So we're going to have some other techniques later in this semester, and then if you go on to Calculus 2, also you'll have additional techniques for finding antiderivatives, and they're not they can be difficult to find, and or sometimes impossible to find in a closed form in terms of elementary functions. But anyway, as a starting point, we'll sort of reverse our process for finding derivatives. So the antiderivative of a constant is just the constant times the variable plus another constant. So the antiderivative of k du is ku plus a constant. The antiderivative of a constant times a function is the constant times the antiderivative. So antiderivative of k f of u du is k times the antiderivative of f of u du. Derivative of sum is the sum. The antiderivative of the sum is the sum of the antiderivatives. Here's the power rule. U to the n. If n is equal to -1, u to the n is going to be ln absolute value of u plus a constant. Otherwise, it's going to be u to the n plus 1 divided by n plus 1 plus a constant. So it's the reverse of the power rule for the derivative. The antiderivative e to the u du is e to the u plus a constant. Derivative of a to the u du is a to the u divided by ln a plus a constant. So those are the exponential rules. Antiderivative of the sine is minus the cosine plus a constant. Antiderivative of the cosine is the sine plus a constant. Antiderivative of secant squared is the tangent plus a constant. Antiderivative of cosecant squared is minus the cotangent plus a constant. Antiderivative of secant times the tangent is the secant plus a constant. Antiderivative of cosecant times the cotangent is the minus the cosecant plus a constant. So these are just reversing the rules for finding the derivative. Antiderivative of 1 over u squared plus 1 is the inverse tangent, and the antiderivative of 1 over square root of 1 minus u squared is the inverse sine. Okay, it's also written this is tan with a minus 1 u plus a constant. It's also written like that. And sine minus 1. That's another way of expressing the inverse tangent and the inverse sine. Okay, so let's go over some examples. If we want to find the antiderivative of x plus sine x dx, so one of the rules is that the antiderivative of sum is the sum of the antiderivatives. So we can split this up into two pieces. And then this is the power rule. It's the reverse of the power rule for derivatives. Instead of subtracting from the exponent, you want to add to the exponent. And so this is going to be x squared over 2. And this is going to be minus the cosine of x. Derivative sign is the cosine, but the antiderivative is minus the cosine of x. And then plus a constant. Again, we can separate this into pieces. This is you have the antiderivative of quantity 4 minus 6 e to the x dx. So we can separate this as antiderivative of 4 dx minus 6 times the antiderivative of e to the x dx. So this is going to be 4x minus 6e to the x plus a constant. The 5 we can factor outside. 5 times the antiderivative of secant squared. Antiderivative of secant squared is a tangent. Tangent x plus a constant. Yeah. So our rule for the derivative is derivative of the tangent is secant squared. So this reverses the antiderivative of secant squared is a tangent. This one, if we factor out the 6 over 5, this is 6 over 5 times the antiderivative of 1 over x squared plus 1 dx, and this is just the tangent inverse. It's 6 over 5 tangent inverse x plus a constant. This one we can distribute the denominator. This will be antiderivative of 1/2 dx, and the 2's will cancel here, minus the antiderivative cosine x dx, and this is just going to be 1/2 x minus the sine x plus a constant. Root we can write it as in exponential form, antiderivative of x to the 1/3 power, and we want to add 1 to the exponent and divide by the new exponent. So this is going to be 1/3 plus 1 is going to be 4/3. Divide by the new exponent, which is 4/3 plus a constant. And dividing by a fraction is the same as multiplying by the reciprocal. So we can write this 3/4 x to the 4/3 plus a constant. We could also express this back in radical form. It was originally in radical form. So for fractional exponents, the denominator is the root, and the numerator is a regular exponent. So it's the third root of x to the 4th power plus a constant. And that concludes this presentation.